Okay, so we're going to be continuing on where we left off in class. We were talking about conditional statements, and conditional statements are written in if-then form. We did a little activity with the DirecTV video that we watched, and we're going to continue on with what we will do with those conditional statements. So we've already discussed a little bit what a counterexample is in class. We had a question with a counterexample in one of our tests. So a counterexample is an example used to show that a given statement is not always true. So all you need to show that a given statement is not always true is one counterexample, and one counterexample will disprove that statement. So as we're going through the notes, I want you to make sure that you write these things down and make your notes complete. So I want to come up with a counterexample for this conditional statement. So it says, if n is a prime number, then n plus 1 is not prime. So if we can find a counterexample where we take a prime number, add 1, and get another prime number, then that would be sufficient to prove that this is not always true. So there's a couple different examples you can use. The one I came up with is 2 is prime, and 2 plus 1 equals 3, and 3 is also prime. So that makes this statement not always true. If you're saying a conditional statement, even though we came up with some funny examples, a conditional statement should be written like fact. So if we're saying if n is a prime number, then n plus 1 is not prime, that should always work. And if once we find the counterexample, then we're showing that this is not a true statement. Every prime number cannot add 1 and get a non-prime number. Another example, if the area of a rectangle is 20 feet squared, then its length is 10 feet and its width is 2 feet. Well, we know that we get the area of a rectangle by multiplying length times width. So if we can find any other numbers that would multiply to get 20, that could be the length and width, then that would disprove this statement. So I came up with a rectangle with a length of 5 feet and a width of 4 feet would have an area of 20 feet squared, because 5 times 4 also equals 20. So that disproves that the length and width would have to be 10 and 2 to get that area of 20 feet squared. If you need to pause the video to get that down, make sure you do that. So now we're going to be getting into how we take a conditional statement and we rewrite it in these other forms. And so last class I had you highlight that if P then Q. Well, now we're going to be adjusting the order of that statement. So we have the conditional statement, which is if P then Q. Then we have the converse. So the converse is taking the conditional statement and switching the hypothesis and conclusion. So instead of saying if P then Q, we say if Q then P. We'll go over examples of all of these. I want you to take your highlighter and highlight that if Q then P part. Okay, so our next form of a conditional statement is the inverse. The inverse is created by negating both the hypothesis and conclusion. So we keep it in the same order. We don't switch them like the converse. We just negate them. So if not P, then not Q. Notice they're still in the order P, Q, but we're saying not P, then not Q. I also would like you to highlight that part. So we're going through and highlighting all these kind of formulas that we can use to help us rewrite the if-then statements. Okay, finally the last one is the contrapositive, and this is a form of a conditional statement created by switching and negating the hypothesis and conclusion. So it's kind of a combination of the converse and the inverse. And so the way we would format that would be if not Q, then not P. So after you copy down these definitions, on the next page, we will go over specific examples. Okay, so this is one of the conditional statements that we went over in class from the DirecTV video. So if you see things you shouldn't see, then you vanish. We could think of the seeing things we shouldn't see is like our P. And the you vanish is like our Q. So when we write the converse, we just simply want to switch the P and Q. So I'll take the Q, I'll put it in the front. It'll still say if. I don't start with saying then. It'll say if, and I'll switch the conclusion to the beginning, and then it'll say then, and I'll put the hypothesis at the end. So that would be, if you vanish, then you see things you shouldn't see. So in the original statement, we're saying that you see things you shouldn't see first, and then you vanish. And then here it's saying if you vanish, then after you vanish, you would see things you shouldn't see, which doesn't make as much sense. Some of these statements will not always be true. Oops. So I'm going to kind of put that up a little too soon, but the inverse is just negating both P and Q and not switching the order. So it would be if you don't see things you shouldn't see, then you don't vanish. I mean, it's just really the opposite of the conditional. So sometimes the inverse is true. Sometimes these are true. We would assume probably that if you're going to vanish, if you see things you shouldn't see, then if you don't, you probably won't need to vanish either. And then finally, the contrapositive is a combination of the converse and inverse. We will both switch the hypothesis and conclusion, and we'll also negate them. So the contrapositive would be, if you don't vanish, then you don't see things you shouldn't see. So we're basically taking the converse and negating it. The inverse is a negation of the original conditional statement, and then the converse is, or the contrapositive is a negation of the converse. So after we copy this part down, pause it if you need to, I have another example that I want you guys to try on your own to rewrite in the 3 forms, and then I will be checking for this in class. So, the on your own, I want you to take this conditional statement. If the animal is a duck, then it is a bird. So, this is actually a true statement. While up, if you see things you shouldn't see, then you vanish. You don't always end up vanishing if you see things you shouldn't see. But if an animal is a duck, then it's always in that category of being a bird. So, this would be a true statement. As you rewrite the converse, inverse, and contrapositive, I want you to also mark, are those statements true or false? Okay, so you're going to rewrite them on your own, and then I want you to decide, do you think that statement is always true? Remember, if you can find a counterexample, then the statement would not always be true. So again, take a minute, pause this video, work out that problem. This is going to be your accountability for me making sure that you do the notes. And I will be asking you in class to fill out a little slip with the answers to that problem. Okay, so this is basically starting a new section of the notes. So I want you to start a new page, make a new header. What we were doing before was continuing on, and this is a new short section of the notes. So we are going to be going over 2 different types of reasoning. And the first one is called inductive reasoning. So, the unit that we're in is on logic and proof, and to prove things, you have to have reasons. So inductive reasoning is just using specific examples to arrive at your logical conclusion. And using inductive reasoning does not ensure logical certainty. So I want to highlight that part. So when we use inductive reasoning, we're just going off of our best guess based on what we observed. We cannot guarantee that it will always work out that way. So some examples of what I'm talking about. So if you observe that the postman delivers mail Monday through Thursday at 1 p.m., say you see him all 4 days, every day he delivers mail at 1 p.m., you might be able to conclude that he would also deliver mail at 1 p.m. on the next day, which is Friday. But that is not guaranteed. There's things that could happen that could prevent him from being on time. He could have a flat tire, he could get in an accident, he could be sick that day. There's the whole bunch of different reasons. So concluding that he's going to deliver at 1 p.m. on Friday is just your best guess. You really can't ensure that. Another example would be it has been hot and sunny for 5 days straight. You might conclude that the next day will be hot and sunny as well, but something could happen. There could be a freak cold snap. Sometimes in our summers, we have this random day that's cloudy and cool and, goes from 100 degrees down to 90 or down to 88, and there's no sun out. So, just observing the 5 days of hot and sunny does not guarantee that the next day will be the same. Okay, and our last page of notes, we will go over deductive reasoning. So remember, inductive reasoning is when you use observations to conclude something. Deductive reasoning is what we use in math, and it's reasoning that uses facts, rules, definitions, or properties to reach logical conclusions. So, all the properties we're using in math, Pythagorean theorem, the supplementary angles, these have been proven, so we're able to use them. So, and we're going to be proving things, of course, that have already been proven, but we're going to learn about how to prove and how it's formatted. And when we prove things, it will be using deductive reasoning. So, for instance, if it's stated that two angles are congruent, then you can conclude that their measures are equal because that's what the definition of congruent means. So that is the type of reasoning that we'll use in proofs, and we are going to go over some activities in class where you'll do some proofs using algebra and using geometric properties. So that actually concludes our notes. If you weren't able to get that down, there it is again. Make sure that you did your on your own practice and decided if those statements were true or false, and I will see you in class.